Okay, it's 3.2, exploring linear relations. Very short lesson. A couple definitions we need to understand though. First of all, the y-intercept. It's the value of the independent variable when the dependent variable when the independent variable is 0, sometimes called the initial value. Okay, what does this mean? Basically, it's just the value that crosses the y-axis, okay? So we all know this is y and this is x. So if we have a line like this, it's going to be this value, okay? That's the y-intercept. Okay. So the x value of this y-intercept is always 0. So for this particular y-intercept, let's say it's 1, 2, 3, 4, the value then, so point would be 0, 4. Okay, so this is y-intercept. Okay, if I now had another graph in yellow, and it looked like this, okay, who can tell me what would be the y-intercept value in this case? I think that's
0, 0.
yeah, 0, 0. Like 0, 0, and that's because it crosses the y-intercept right at the value of 0. If I had another graph, say blue, purple, like this, who can tell me what the y-intercept of that purple graph would be? Carlson?
7. Yes.
That's right, yeah. And we'll do one more. Orange. Tell me what the y-intercept of the orange graph would be. Marnie.
0, 8.
Good. Okay, so y-intercept then, when the independent variable is 0. When is the independent variable 0? It's the y-axis here. Yeah.
Isn't it negative 8? Yeah.
Sorry, yes. Thank you. Yeah.
So the first, it will always be on the x-axis and always be 0.
Yes. The x value will always be 0 for the y-intercept, yes.
And then it's to wherever it connects to the.
Yes,
Okay.
exactly. Okay, that's y-intercept. Direct variation is a relation in which one variable is example of the other. Sorry, is a multiple of the other. So this is y-intercept. This is example. So that's these values here, right? There, there, and there. Those are all y-intercepts. Direct variation, a relation in which a variable is a multiple of the other. So, as an example, we can have y equals 3x. That would be considered direct variation. Okay. Another example could be y equals 15x. Or y equals negative 2x. Or y equals negative 10 over 80x.
So why is that?
Sorry?
Why is that?
Why is that? Because one is just multiplied by the other. Okay, it's going to make more sense when we get to partial variation. But all of these would be examples of direct variation. Okay? Yeah.
Is x still equal to 0?
For the y-intercept, yes, for these it is.
So how about for the direct variation?
Sorry, ask that question again?
You see those expressions over there?
These, yeah.
Is x still equal to 0?
Not necessarily, no. X could be 1, could be 2, 3, 4, 5. whatever. The point is, this is direct variation. Now, if I were to graph these in direct variation, okay, we're going to make a graph now. So when y is 1, I'm going to do kind of a table of values in my head. So remember, I'm going to choose the independent, which is x goes along the horizontal axis. Let's choose 1 for x. Y is going to be what? If I choose 1 for x, y is going to be? 3. So I go x1, y1, 2, 3. Okay? If I say x is 0, what's y? 0. Okay? If I say x is 2, what's y? 6. So 1, 2, 1, 2, 3, 4, 5. Okay, so I get this graph. Okay, and it's consistent, it's a straight line. Okay, this is direct variation. Okay, because 1 is just a multiple of the other. So this is direct variation. Let's do the next one now in orange. Y is equal to 15x. Well, when x is 0, y is what? 0. It's still 0. Good. Or when x is 1, y is what? So 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12, 13, 14. So I have this line that looks like this now. It's extremely steep. Okay? Almost straight up and down. But this is still direct variation. Okay, because 1 is a multiple of the other by definition. Next one, y is equal to negative 2x. We're doing purple. So when x is 0, y is? 0. When x is 1, y is? So I'm going to go 1 and then minus 2. So I go out here. When x is 2, y is? Negative 4. 1, 2, 3, 4. Okay. How about when x is negative 1? Y is going to be negative 2 times negative 1, positive 2. So up here. So I get this line now. Okay? So that's also direct variation. And finally, this one, it's a negative slope, so again, it's going to go in this direction. The x value is very small, so when x is 1, y is only going to be about anyways, very small, like 0.12 or something like that. So when x is 1, y will be negative 0.2, so let's do this one in yellow. So when x is 1, y is negative there, very small value, less than 1. So we get a graph like this. Okay? Notice that still when x is 0, y is 0. Okay? So what's common about all of these in direct variation? Yeah.
They all pass through 0.
Good. So in direct variation then, I can say the y-intercept is always what? The y-intercept, where do we cross the y-axis? 0. Okay? The direct variation, our y-intercept is always 0. If we do linear relation now, a relation in which the graph forms a straight line. Oh, sorry, partial variation, my bad. It's a relation in which one variable is a multiple of the other plus a constant amount. So, as an example, I can do y equals 3x plus 1. I can do y equals 15x plus 5. Y equals negative 2x minus 1. Okay? All of these are examples of partial variation where we have a component that's direct plus this other number. Or it could be subtracted as well. And so the way we graph those now is very similar because they have the same slope, you can see I've chosen the slope to be the same. So what's going to happen now? When x is 0, y is going to be what in this particular case? So in this graph now, when x is 1, when x is 0, y is 3 times 0 is 0 plus 1 is 1. So when x is 0, y is 1. Now when x is when x is 1, y is going to be 4. You guys see that? So x is 1, y is 1, 2, 3, 4. So what happens then is we get this similar graph, but it's just been moved up. Okay? And likewise, for the next one, y is 15x plus 5. We're going to get this same extremely steep slope, but it's actually going to be moved up 5 values. Okay? That's because when x is 0, y is actually 5. So I get this graph now. 1, 2, 3, 4, 5. I get an extremely steep graph like this. Okay? When y is equal to negative 2x minus 1, we're going to get this purple graph, but now when x is 0, my y value is not 0, it's actually negative 1. So I have this graph. Okay? So same slope, same angle, except your y-intercept has moved. So this is called partial variation. Partial variation. You should think of equations that look like this, and you should also think of y-intercept varies. Okay? What's the difference between partial and direct variation? In direct variation, my y-intercept's always 0. Partial variation, well, my y-intercept's going to change. It's going to vary. Yeah.
Sir, if x is if it's equal to 0, wouldn't all those things like the y-intercept, wouldn't they still be 0?
No, because look, plug in 0 for x here. So you get 3 times 0 plus 1. So what's y? Yeah, this goes away, but your y is still 1. Okay?
0. Oh, okay, now I get it.
Yeah, it would be 0 plus 1, right? This would be 0 plus 5. Yeah.
So doesn't that mean that y will always be the constant?
Yes. You're right. This is your y-intercept. Good. The equations that are this simple, you can see that this is your y-intercept. And that's going into tomorrow's lesson. Okay? Good observation, Michael. Yes. And finally, the last definition, a linear relation in which the graph forms a straight line. So all of these would be under the category then of linear relations. Okay? Why are they all linear relations? Well, they all have a straight line. Okay? And for the most part, we only look at linear relations in grade 9. In grade 10, we'll start to look at quadratic relations, which are curves, okay, or parabolas. But for now, we're looking at mainly linear relations. Any other questions with this section? Okay, that's it.